I was wondering how, I'm very interested in your approach, and I think you're doing really important work because we need the exposure element to this whole risk equation as well. How do you feel about the usefulness of city ordinances like Berkeley's or Cambridge, Massachusetts, considering it, in the reporting requirements for getting exposure estimates? So that's my first question. And then the second question is a more technical one. And how do you go from production to release in the environment? I mean, how are you going to get, the amount produced is not the amount that's going to be in waste streams, coming from the effluent or what have you. There's going to be a conversion factor there that you're going to have to develop. And so those are my two questions.
Okay. The first one, I sort of like the idea that cities are working with the businesses to do sort of self-reporting. And like DuPont and the Environmental Defense have a Nano, have you guys seen it? It's basically the risk framework that it works with companies to sort of self-report. And I think that, I guess it's just good to get more information out there sooner, just because if there is some sort of outcry about danger, and what if asbestos gets stuck in people's head as it's definitely going to be this financial and health disaster, then to counteract that, we can, this time around, we can say, well, no, people are already looking at that, a little bit, there's balance that way. And I think that a lot of the, Steve Carell's work has, which is doing surveys of public perception of nano, has shown that people still have pretty much a positive response, and so they don't feel like afraid of it yet. So I think that in that aspect, any sort of information collection is only a good thing for now. But I don't know that it can only be information collection, because like we said about context earlier, even if Berkeley collects, this much is being released into the environment. So I don't know, is that bad? Is that fine? Or so I guess as long as it's just realized that it's information collection, then that's not harmful. And then the second part, we've looked at a couple different ways of trying to make that conversion factor. The insurance industry algorithm that I used in the previous proof of concept, what they did is they asked the companies, and this is how they really set their premiums. So there's like 12,000 different chemical production methods. They asked the companies, okay, for every metric ton of product X that you produce, how many kilograms are released of these byproducts and the inputs? And so they would estimate it. And most of the time they would just say like, oh, probably it's an order of magnitude thing, so that it falls into bins. So that it's either like 1 through 10, and 10 is like a 1-to-1 ratio or something, and then it goes down from that. And what I found is that most of those companies, or the insurance adjusters that were building that algorithm, would just say what they thought it probably was, and they were like, oh, that's only a minor ingredient. So I bet you that it's like a tenth of whatever is finally made is released. But then we also found that like bigger companies had much better recapture and recycle, just from a financial perspective. They couldn't afford to waste. So we could look at that route of just trying to, for each part of the process flow, estimate what would be a percentage released. Another thing that we're thinking about doing in our group, and if anybody has ideas about ways to be more relevant, we'd be happy to take them. But we were thinking of, so you saw that 50% of titanium dioxide right now is used in paints. So what if we just look, if we just do a series of samples downstream from either a paint company, or also the runoff water that could have come from the from surfaces, just kind of thinking about the main sources that will be out there for each, and this is case specific, so it's a little tough. It's similar to the toxicology problem where you're saying like, where do you even start? It's also different, but maybe looking for a specific nanomaterial in its main use, and where you might expect to find it, which is in water for titanium dioxide, and maybe runoff water from paint surfaces. So I think that's it. Thanks.
Yeah, just an observation, I guess, for you're mainly concerned with water pollution, I guess, here, but in air we used to use the larger size titanium dioxide particles more as a negative control particles, like some of the ones I mentioned. And then some papers came out, I guess, with nano size that was very surprising to me, that before I knew anything about nano, that they were actually fairly toxic. I don't know if the same is true in aquatic systems. Maybe Tara could comment on that, but with nano versus larger sized titanium.
Yeah, because I don't know the size range at which, like, if it's maybe under like 100 or 80 nanometers at which you start seeing that the additional surface reactivity that causes different behavior. But that's one of the other things that we're looking at as a group, is to try to list out the different parameters that if we were to use a similar risk assessment algorithm like the insurance industry one, they would say the first step is, say if you have a titanium dioxide, you have to know the size of it, the half-life in air, half-life in water, KOW, those kind of things, and some of those things no longer obviously describe the end outcome anymore. Like if it's mass concentration, well, maybe in some cases it should be surface area, concentration. So we're looking at what of those parameters in a simplified model, even a simplified ranking model like that, would need to change to account for that. Exactly what you're saying. You can't just put titanium dioxide this much anymore. So
With the increase by 2025 going completely to nano size, I mean, that's amazing. Do you know if the nano size aggregates or agglomerates?
It does.
And so, but even then, the surface area is different from the larger size. So is it more, even when it's aggregated, do you know if is it more reactive? Is it more toxic?
I don't know that. I know we've done in our group a lot of work on fullerenes, and they seem to be less so when they're aggregated, just because I guess there's less available bond sites and the chemistry's changed. But I also think, and this work hasn't been published yet, and I think there are a lot more caveats that are going to take that number 2025 all the way down. But it would be, that's a good idea to add in, the different things that might change the toxicology of the final product, because so many of them are going to be coated or aggregated or in some way modified from the way that they're produced, that it'd be interesting to see, in the different, like in the catalyst, for example, for that product, it's going to be in a matrix and maybe less available. And paints, it could just be washed off, and then maybe it just goes out there and isn't so aggregated. So it's going to be specific.
I have a question from Martin Kloberg. Two questions, I guess. You mentioned that in the U.S. there are only 4 companies at 8 locations that produce nano titanium dioxide. Do any of these apply these nanoparticles in manufacturing consumer products, or are they exclusively precursor material suppliers?
Oh, that's smart. Okay, so you're saying that out of the 8 current producers that report to USGS, only DuPont is known to produce nano-sized titanium dioxide. And they sell it as a premium specialty chemical now. So most of the people who buy it now are for R&D for different product development, or labs for, like we buy it basically now. And also the cosmetics industry, which is a tiny, tiny percentage of what titanium dioxide is used for, but a huge percentage of the nano use right now. Another interesting thing, I'm glad you asked that question because I didn't say this. All of the other nano titanium dioxide producers have, like the 4 or 5 that I mentioned, they have no intention of producing nano titanium dioxide. They're technology companies. So they're intending to make a technology and then sell it to these people. So, for example, like Altair Nano, which is the one we based that entire estimate on, they sold their patent, they're licensing it to the Vietnamese national company. And so it's not like those people are going to try to get in there and be titanium dioxide players. They don't want to be in a commodity market. They want to stay specialty chemical and just spin off their technology. So that